So, when looking at this here, again, we're going to have, using the derivative or the quotient rule, we're going to have cosine of x times d over dx of sine of x minus sine of x times d over dx of cosine of x all over cosine of x squared. Now, you could have used the f and the g, right? But I don't want you guys to have to do f and g. Like, there's other ways to represent the derivative of two functions, right? Derivative of the bottom function times the top minus the top times the derivative of the bottom divided by the bottom square, right? It's all the exact same stuff. All right, so let's figure out this out. We have cosine of x, derivative of sine of x is cosine of x, minus sine of x, derivative of cosine of x is negative sine of x. These are multiplied by each other. All over cosine squared of x. Well, cosine x times cosine of x is cosine squared of x, minus negative times negative is a positive, sine squared of x, all over cosine squared of x. Cosine squared plus sine squared, using the Pythagorean identities taught to you in pre-calculus, is 1. So you'd have 1 over cosine squared of x, which is equal to secant squared of x. Okay? Yes?
When you're doing like the second step, is it okay to write d over dx equals all that? Or do you do like the brackets?
Yeah, I wouldn't use equals. I would just say you're taking the derivative of sine of
Not
x.
for that, for the next one. You have to carry it down for the, you know what I mean?
I would just use parentheses in there. I
No,
mean,
not for that, not for like the entire like, expression.
oh, yeah, I mean, you could still, well,
How do you write
it kind of gets a little bit more, yeah, it's, I mean, if you have this equals, you're basically saying d over sine of x equals this, which equals to that, which equals to that, which equals to that, which equals to that.
So that's how you write it?
Yeah, I mean, because basically, I just did this, instead of writing the steps over here, which are random space, I would have done this, and then that, and then I would have gone down like that, right? So yeah, these are, this is, since we're not doing a y or an f of x, it's just, this is an expression you're taking the derivative of. So the derivative is equal to all of those. And then I just summarize that again.
So for the next one, you just write equal sign on by that?
You would still need to write, as far as a, I would still expect that you would have a final result with something like that. Yes. No. No. Cosine squared plus sine squared equals 1. It's a Pythagorean identity in pre-calculus.
Oh, okay.
Okay. Yep, and then it's 1 over. Yes.